Hello. This stream is going to be a shorter one than the rest, and it's also going to be a little different. Just going to do Code Wars, because I started late today. So it's all the time you really have to completely do. Don't really want to jump into a project and only complete half of it. So, as usual, going to be doing some Code Wars. We'll drop the links in chat accordingly. But first, I'd like to thank everyone who followed while I was offline. Lee 1097, of course, notification. There it is, now it's fixed. Okay, don't know how, I'm probably going to fix that eventually, but it's good old CSS loading late. Pascal codes, appreciate the follow. And I'm gonna get this name wrong. Rajabilial. That's the best I could attempt. I still appreciate your follow. And lastly, Silent Spy. Thanks for the follow. Okay, so nothing but Code Wars today. I already picked one out. Deep comparison of objects. So let me drop this one in chat, and I will go through this one first, and then we'll jump to a next one, or if anyone has suggestions, jump to those ones. So, comparing objects, comparison operator, only true, point to the same object. Develop the deep compare function that tests if two objects have the same properties and values. An object can contain other objects, so that's going to tell me this is going to need to be recursive or something. Functions should be able to correctly compare simple values without using type coercion. Only deal with simple values and objects and arrays containing strings, booleans, and numbers, so only primitives, without taking into account regexes, dates, and functions. So not the worst, like there's not a lot of things we need to compare, but it's most of the primitive things, so it's gonna be not the easiest, but at least not the most challenging comparison operation we need to do. So first, the easy thing to check is if the types are different, because if the types are different, then they have to be different. So if type of O1 not equal type of O2, then we're going to return false. Now at this point, we're going to assume they're equal. So what we can do is we can check, so this will deal with primitives, so our strings, numbers, and booleans. So if they happen to be strictly equal, if O1 triple equals O2, return true. So this will handle all our primitives. It'll also handle any objects or arrays that are pointing to the exact same thing in memory. Of course, I forgot to start the timer. Hey. That seems about how much time we've spent. So that handles anything that's not obviously the same type, and anything that is primitively the same type. Now to deal with actual objects. So, I'm trying to think the optimal way to do this. We essentially want to go through, so there are a couple ways to do this. Let's start by going through all the keys of the first object, and we'll see where we go from there. For const key n, using the n operator of O1, we're going to check if key not n, except this ain't Python, we can't write that. So we'll grab the current value, const value equals O1 key, and we'll get other value, const other value equals O2 key. Now we can do some comparisons where we can be efficient, maybe not efficient, but we can be as dry as possible and reuse deep compare. So if not deep compare value, other value, return false. Because remember, this handles automatically on the first two lines types that aren't the same, and this handles primitives. And then this, of course, will handle if these are two are objects. So here we will return true. And this may seem like it will work, but it doesn't work. Should detect when a property is missing. So if we console log our objects, we'll see exactly why this is failing. I'm pretty sure I know why, because we're only looking through the keys of O1. What if O2 has a key that O1 doesn't have? We don't even look at it. So, should deal with the property is missing. Expected true to equal false. Okay, so I'm looking here. O1 equals Joe, O2 equals Joe. Okay, so it's kind of hard to tell because we are calling this recursively, but eventually it becomes a call up to, so this is the original call, the original object. Maybe I'll add a depth thing up here. Depth equals 0, and let's put depth. This will make it more obvious when we're calling recursively. There we go, and depth plus 1. Of course, I need to use a comma, not a dot. There we go. Now we rerun this. Our console logging will be much more informative. So here we go. We see depth 0. So O1 is this, O2 is this with an additional property. So O2 has more keys than O1. And then it's called here, which returns true, but surname is never checked on O1. How do we do this? Well, we could do the inversion. We could just literally say, okay, we'll flip it around. O2, and then O2, everything with O2 becomes O1, essentially. And this will probably work. Okay, this won't work. Never mind. Order is important with arrays. Okay, so this is handling arrays for us automatically. Did not realize that. Let's see. So we have O1, 1, 2, 3, 1, 3, 2. So this isn't what I was going to go over initially. It wasn't what I was going to fix, but we're here now. Might as well give it a shot. So let's see. O1, 2. So this is false. Expected true to equal false. If not, return false. Okay, let's get rid of for key 2, 1. I'm making sure that I didn't mess this up on the inverse. This should be returning false because these aren't equal. So yeah, if types are not the same, return false. If they're strictly equal, return true. But then if they're not strictly equal and the types, okay, I need to handle the primitives. So if type of O1 not equal object, turn O1 equal O2. And I'll explain this if it works. Okay, it works. So what happened is we were coming in here with two numbers, 1 and 3. Now, they weren't equal, so it never returned true. But then it tried to do some key equality. For key n1, that loop didn't go nowhere. For key n2, that loop didn't go nowhere. So it returned true. So what I needed to do is make sure, okay, if they're not objects, then you must use the strict equality or the strict comparison operator. Otherwise, then we use these loops. Now these loops are obviously very wet. How do we optimize this? Well, I'm not really sure off the top of my head, but I know some ways to make this a little cleaner. Maybe not as optimal, but essentially we need to go through all the keys and check if we haven't seen any in the other one. I believe is the way to go. Yeah, so we'll just go with a const scene equals new set. Using a set, we won't use a set, we'll use an array just for simplicity. Then we'll add this one to scene. So scene.push current key. Now we're going to go through the second array and we're going to say, hey, if the scene includes key, so if we've already tried this, then continue. Let's not try this again. Of course, include is not a function or a method. Includes is plural, and that works, and that works. So it's more performant, but still a little wet. So how do we do this? So essentially, we need to basically grab all the keys first. So const keys 1 equals object.keys o1, and then we'll replicate this behavior for second one, like this plural, keys 2 equals o2. So first, since we've already done this, we can do an instant check to see if the length of them are different, which common practice. If they don't have the same length, then they obviously don't have the same keys. So if keys.length not equal keys2.length, return false. Length, and it's supposed to be keys 1, not that one. There we go, so that's the first half of it. Now, to optimize this any further, instead of we will combine them into all possible keys. So const keys equals a combination of both of them. Now, we can implement our own deduplication algorithm, or we can use a set. So a new set of keys 1 and keys 2. So those are all our keys, and now we can iterate through them without having this double loop to go through the keys in each individual object. So for key in keys, now we don't need to use scene anymore. And of course it don't work because I forgot something. Order is important with arrays. Yes, so the duplicates are removed, but it is flattened into a single thing. This shouldn't be a problem. So let's see. We have keys length is different, correct. All the same keys. Key and keys. It doesn't seem immediately wrong. Let's do some more console logging. See what that key is. Okay, let's see what... Oh, yes, so good old in operator. In goes to the enumerable properties of the thing. This is a set. It has no enumerable properties, unlike an array. So you need to use the for of loop. So if I had used an array and just deduplicated it, this probably would have worked. Actually, this wouldn't have worked because it would have gotten the keys of this new array, which would have been the indexes, not the values. So I always got to watch out for that. Whenever you change data types on what you're iterating over, make sure you're using the correct of or in if you're using these fancy new for loops. But that, I mean, it passes the test. We can clean it up, clean our variables up at least. Reducing a little duplication, reducing a little more duplication. I believe we still need to have both of those. Now we could avoid the length check, so this would optimize only variables, I believe. So this would actually be less performant, but perhaps more clean looking for larger objects. Because eventually one of them it'll essentially the same thing, just you're not doing the early check. But it does make it a little shorter. And of course we don't need the actual depth going around here. That was only for debugging. You can say goodbye to that. And I believe, like I know the performant one is make sure the lengths are equal. But this one looks pretty nice. Yeah, so last before we go, making sure that they're of the same type. If they just so happen to be strictly equal, be it because they're primitives, or they reference the same thing in memory, free return of true. If they're not objects, and this goes for both of them, because you've already verified the types are equal. So when we're doing type of O1, we're also doing type of O2, since they're always equal, thanks to this check. So if they're not objects, which means there's some form of primitive or function or etc., then we want to use strict equality, because we want to check if string equals string or if number equals number. Strict equality operator thankfully handles it for us. And lastly, we will grab all the keys of both of the objects and remove the duplicates of them. So we want all the keys of both objects, but we don't want any duplicates. So we put it into this array, then we pass that using the spread operator, and then we pass that array to set, which we haven't really learned just yet, but what set does is it takes a bunch of primitives, strings, numbers, etc., and removes duplicates. So if you pass an array with 2 ABCs, it'll only get 1 ABC, and it does this kind of silently, kind of automatically. You can think of it as so when we have an object, so if we have ourselves an object, then we have closing object there. All the keys of it are unique. This is the same thing as a set, where you can think of a set as just the keys of an object all alone. I'm trying to think if I can optimize this any better. I don't think so. Let's see how the others do. Okay, they do strict equality first. That's probably a good idea. Checking if neither of them are objects. Okay, checking that the keys lengths are the same. That's good. And then they're going through the keys of object 1, making sure that every key... So they're not actually doing the object 2 check, which is interesting how it passed. Oh, because they did the length check first. Yeah, if this had more tests, this would have failed. Okay, we're going very one line all the way. Let's see. We're using instance of. That is a more modern way of checking for types. Does a little more than just type checking. Someone cheated. They imported low dashes is equal. Yep, literally just gave it low dashes is equal. Ooh. Some tree shaking with low dashes is equal. Okay, and check that every key exists in every other thing. Oh, that's the deep equals, deep compare. Okay, it's an interesting way of just determining to use the strict equality operator or use the special function. And all these lovely one-liners. Yeah, I think that's basically that one done. Let's see a second one. What I have not trained on, and we'll see what this synthesized one is. She got a 5 Caillou. Given a set of input-output, synthesizes a Boolean function that takes on the behavior of those examples. Let's synthesize the function. Oh, okay. True, false, false, true, false, false. Huh. I'm curious what this... Oh, it's only in Python. I'm not really interested there. Let's get back to our 7s. Well, that one looked interesting. That filter unused digits. Let's check this thing out. I mean, it was a 7. Giving a varying number of integer arguments, return the digits that are not present in any of them. Oh, okay. The digits in resulting string should be sorted. That's an interesting caveat. So 1, 2, 3, 4, 5, 6, 7, 8. Missing 0 and 9. I bet there's a math way to do this, but I can't think of one. Okay, so let's see. What is the plan here? So first, I'm going to... So I'm trying to think of... Okay, I shouldn't think of the optimal way. It's just the normal way first. So the normal way first would be keeping a track of unseen digits, and then for every number in this array, and they did not give me the arguments, so they did not give me the rest parameter, I mean, because they're passing it here, but wasn't receiving it there. So for every number in this, I'll convert it to a string, and then for every character in that string, aka for every digit, I will remove it from the unseen array, and then I will return the unseen array joined back as a string. So let's go do it that way first. Const unseen equals, it's gonna be very amazing. Oh, you know what? I'll do 0. I'll just type it out manually. 9. I'll use 2. I'll use split, convert that to an array. So now that's an array of 0, 1, 2, 3, all that good stuff. Then we'll start iterating over the numbers. Const number of nums. I'll rename args to nums. We want our variables to mean stuff. We'll, for const digit of number, to string. So now we have a current digit, and we want to remove that digit from unseen if it exists. So if unseen includes digit, because we don't want to remove it if it doesn't exist, because we can't remove it if it doesn't exist, or if it doesn't contain this digit. Now to remove it, we are going to use the splice method of an array. So we'll do unseen.splice. Now splice takes 2 arguments. Well, it takes 1, 2, or any more after that, because the more after 2 are all, it is a rest parameter, so it takes as many as you want to give it. But the first one is where to start removing elements. Now we want to start removing elements at whatever index the digit is. How do we find that index? Well, there's a method for that. So it's unseen.index of, and you pass this whatever primitive or whatever thing you want to perform a check on. So it'll be checking for digit. And it'll return the index of that digit. Now we can be confident that this is going to be accurate because we've already proven that it's already in here. If we didn't check that it was in here, index of returns -1 whenever it can't find what it's looking for. So it's not going to do that since we have written it accordingly to make sure it already exists. But if we didn't do that check, then we would have to handle that -1. But we don't, so it's always going to be in here. The second argument to splice is how many elements to remove. We want to remove 1 element, so we hardcode a 1 in. The additional arguments to splice are what to insert at this index after removing this many elements. We're not adding anything. So that is our removal. Now we want to return the unseen digits. We'll want them as a string. So we'll join them back together with nothing. And that works. Now let's optimize this. Let's see if we can optimize this. So firstly, let's talk about our data structures. Arrays are good, but includes is a O of n operation. Now, it's not really n because we have 10 digits, but still, we can optimize this by making this a set. It's a slight optimization. And now that we are passing it to a set, we don't need to split it because set takes any iterable, strings included, and it will convert those to its base parts automatically. Now, since we're using a set, we can't use includes, we have to use has. And again, since we're using a set, we have to use remove, or I believe it's called delete. And we don't pass it an index, we just pass it what we want to delete. And lastly, sets do not have the join method. We have to convert this set back to an array, using the spread operator in this case, and then join that into an empty string. So slight optimization, mainly just in data structure. Now let's see if we can go further. Last I checked, delete works even if it's not in the set, which it does. So that's a cool thing about sets. You can remove stuff from them, and if it doesn't exist, it doesn't blow up, it doesn't throw an error. It's like you wanted it gone, and it's gone. It was never there in the first place, but you didn't care about that. You just wanted it gone. So it's gone. It's doing its job. Can we do this any better? And we can turn this into a giant reduce, maybe. Be all fancy that way. Go Codewars classic. Don't really see a purpose in that. So this might be the way we submit it. So again, we're keeping track of all the numbers or the digits we haven't seen. Going through every number in the numbers rest parameter. Going through every digit in that number's string representation. Then we are removing that digit from the unseen set. Finally, we are taking the unseen set, converting it to an array using the spread operator, and joining that array with an empty string, so that way we get the values of it joined together with nothing. Let's see how the Codewars folks did this. Regular expressions. I knew. Why didn't I think of a regular expression? There'd be one in here. Okay, let's see what they did. So they created a dynamic regular expression. So replacing all of the characters. Okay, so what they did is they turned it into one giant number, and they replaced all of the all the times those digits appeared with nothing. Okay, that's actually a unique regular expression twist on it. For digits, they joined all the arrays, they joined all the elements into nothing, creating a single thing of digits. Yeah, so that is the optimization I did not think of. The rest of these are indexes, filters, variants on the same idea. So yeah, probably could have optimized it that further step, but that's okay. And believe that's our break, so... Oh, not 1500. 300. Take a break, take a drink, take a stretch, all that fun stuff. And I will find... Oh, I just realized I never dropped this one in chat. There we go. I will find a new one and then take my break too. What's this one? Hey, they call me Wolf. So the top left clock I am using is actually my own clock. The secret is basically so it's a little create React app because this entire overlay is just myself. So it's this picture just cropped and stuff, and I put text over it and a little JavaScript to make it count down. So it is completely manual. If you're curious about like the clip path of it, like the whole it looking like a clock, that is using some CSS clip path to it's 360 animation levels for each degree, and I programmatically figured it out and then wrote it out so it would kind of tick. And yes, Gene, the VODs are available. They're available on Twitch for 14 days, and as soon as the first one expires, I'll be re-uploading it onto my YouTube, which I don't have linked, but there's nothing on it yet, but I will link it when there will be stuff on it. Probably figure out where that is. So might as well link it now. Got nothing better to do. But hey, yeah, thanks for stopping by, Gene. Which terminal am I looking for? There it is. Close that. Open that. CD stream overlay. Nope. There we go. I'll go ahead and show this because I'm not really working on it. I'll just show it so you can see how the clock really works. Yeah, fancy homemade React.js clock. So it's a Create React app. It's called Stream Overlay. Not too crazy, but this is the timer that basically is. So we have boring timer logic, just like counting down. And this is React.js if you cannot recognize it. Popular. I mean, you probably heard of React. It's pretty popular. Basically, it does all the counting, and then you get the actual timer where title, description. This is all from what's in big mode, but when it's in little mode, like it just has dimensions because I can drag it around. It has the timer text, which is minutes did the math to figure that out. Seconds, math to figure that out. Padded it accordingly. And then we have, here it is. So here's the background image. Then you have the foreground image, which is the red going on. Some CSS to handle the animation changing. Hey, yeah, so you know exactly what you're seeing here. You get to look at my bad React code. And yeah, so that's the React part of it. And then the styling, which is somewhat interesting. You're going to judge my badness on this. So we have an animation somewhere around here. And then here is how I actually got the animation working. 360 keyframes for every degree. Yep. Isn't it just amazing? But it works. It works. Probably the least performant CSS you could write, but it does work. Yeah, I think I ran it like some little script to run through all the calculations and just like grab the computed style and put it in a thing. But that is like, it's using like clip. Yes, it is very much. It's not good at all, but, and you can see like most of them are all just decimal duplicates, which I think CSS is like accurate to what? 3 decimal places, then it stops counting. So most of these are probably, as far as CSS concerns, just duplicates. But it's my code, so, and I'm the one using it, so it doesn't really matter. But it works, doesn't it? If I hadn't have shown you, like, you would have been like, ooh, that's an amazing animation. It's like, no, no, no. You don't know how bad this is. But yeah, CSS, it's clip path, the magical clip path, if you wanted to figure it out yourself. But yeah, that was a good one. And yeah, let's do another Codewars. I could move on to a project. I only got like an hour and 20 though. See if we can find an interesting Codewars. Sum of all arguments. What's this? Oh, I gotta do this one. Okay, we're gonna do this little Codewars then. It's just asking to be done. If anyone wants to follow along, sum of all the arguments given. So, args, gonna pull out the reduce, as is classic when mathing stuff together. Oh, that looks interesting. Let me grab that. Oh, sorry. New thing. There they are. Where'd all my Firefoxes go? They're in the back. The Wolf Watch. Oh, wow. Okay, you got some serious looking good CSS here. Let me drag this on the screen. Yeah, this thing's real fancy. Got no idea. I'm not a watch connoisseur, but that's something, alright. Oh, okay, cool. We got city. Maybe I'm not doing that right. Don't mind me just looking in the console. Network error. Cores. Okay. Oh, that's okay. Yeah, everything. But hey, most of it worked. I just pretend I didn't click on that. Always love me a cores error. Oh, a stopwatch too. Nice. Oh, there's no JavaScript in there. That would make sense. Hey, Nene, 0419. Yeah, I do stream. I'm starting like less than a week ago. Yeah, I got the cocktail picker, got the NASA thing done, got the animal picker halfway done. I was gonna be doing an online trivia, multiplayer online trivia, but one, I saw Mayan Wolf was doing Jeopardy, so like I didn't want to do that. I want to be more unique. And then I saw the I ran out of time. Like I didn't start the stream as early as I should have. So I'm gonna push that multi-user online trivia game to probably not tomorrow, but Friday or Saturday. But yeah, they call me Wolf. I don't know if this is related, but get a CORS error for ipapi.json. Maybe this used to be CORS friendly, but yeah. Ooh, a Trivial Pursuit, huh? Okay. Just gonna Trivial Pursuit API, don't mind me. So this is the one I'm gonna use for a little. I mean, it was on the public API list, but this is kind of like the general trivia API I found. I'm gonna use this one. Didn't realize the Jeopardy API even existed till I saw Mayan Wolf's message about it. But yeah, it's not gonna be this stream, but eventually I'm gonna make it, and I'm gonna make it multiplayer. But I'm not gonna use any backend stuff. I'm gonna use Peer.js. Now, I haven't really used this in a full project yet, but this basically allows peer-to-peer communication between browsers only. All you gotta do is find out a way to like have one user give another user their ID, like Discord or whatever. So that's what I'll do. But this is how I'm gonna make my online trivia game multiplayer, and it will be Jeopardy style. So like, if you have other people join, y'all gotta clock your answers in. You know, kind of like Jeopardy if you haven't seen the show. Yeah, my NASA. I mean, I didn't really go too far in the NASA. I only went for the astronomy picture of the day. And I didn't even, like, that's when I was gonna stop. But then I found out, oh, this thing has a random button. So this is what my NASA project looks like. This is it. I have the current date and a date picker here. You shouldn't be able to click future dates, but I have little buttons that like next and previous. Yeah, Wolf, don't blame. I know the feeling. My random animal picker API, like the day I made that, I was like, ooh, I'm gonna add like 5 APIs to this thing. Like one API for cats, one for dogs, one for fish. And the second API I had CORS. So I was like, oh, I'll find a CORS proxy. And then like, it kind of just slowed the whole thing down. So I know. But yeah, this is the NASA thing I whipped up. Nene. Got the random button. I got the date button. That's about it. Ironically, what I'm most proud of is this field set. It has nothing to do with the API, but it just toggles nicely when you click it. But yeah, I mean, this Wolfwatch, it does do a lot of cool stuff on it. Just, you know, every now and then, every bug doesn't always work. Close, refresh. Yeah, Nene, of course, happy to help. Oh yeah, and I mean, I know you're gonna do it yourself, but in case you wanna, nope, close one more tab. Oops, over here then. I'll find it. Here it is. If you ever get stuck on anything particular and you want to try to read my code, if you want to try to figure out what maybe you're missing, if someone on the Discord can't help you directly, you can see that. You can see the magic behind it. I'm curious. Hope you don't mind me inspecting around. Ooh, we got SVGs. Fancy. Fancy SVGs. I mean, it looks very good. If you're any bit of a designer, like this is definitely a good looking piece for sure. I still don't know what this button does, but it's really fun to click. Yeah, let me close these tabs. Yeah, sum of all arguments. This is a fun one. But yeah. Feel free to come by, share it again if you make some improvements on it. Yeah, I love seeing how people make things work because I'm no designer. You can, if you couldn't tell from my previous work, I don't really do the design. I kind of like find the design and be like, that's really cool. I'll just like put it in the bottom, be like, I got this cool design from this person. But I am more of a functional person myself. I'm curious on how the inspect. Does that not let me? Okay, there we go. Oh, there's a button in there too. Oh, that's that button. Okay, yeah. This is a hovered state. Use href symbol. Look at all these things I never heard of. Well, I mean, it's a very good looking anime. I thought it was like one of those like watches that like told you how far you along in the year and the month and the day and something like that. That's what this thing kind of reminded me of, like, because there are three rings. Yeah, the hours. That is the challenging part. I think like there's literally like elite code style prompts, like if you're going for a front end position, where they're like implement the hands of a watch pointing where they need to point when given a certain time. So yeah, it's definitely not a trivial thing at all. Let's see. Oh, here are the hands. Minute, hour, modal. Okay, that's a slide down thing. Yeah, an actual GitHub that would make it easier to inspect. Ooh, web dev, webpack, yarn, pretty, you get all the fancy tools on here. Let me see. Oh, cool, cool. Yeah, it's a pretty cool project. Just gotta get the rotation on these. Let me see if I can remember how this works. Rotate 150 degrees. Somewhat like that. Maybe about 180. Less degrees. Yeah, there it is. Woo! Minute. Oh, I guess. Oh, yeah. All the hands are currently stacked or something. Oh no, I applied it to literally everyone. No wonder it's. Why are all the hands rotating? Because I told all the hands to rotate. I want just this one to rotate. Transform. Nope. Transform. Rotate. Oh, it also needs to translate, don't it? Yeah, it does. Yeah, we got rotation. Oh wow, this is gonna look really good once you get this hooked up. Yeah, I mean, I definitely say you're about bang on the money with the design and replication for sure. And yeah, Webpack, it can be an experience. I started like I did it once all on my own, like because I saw all the automagical stuff like Create React App did, and I was like, I don't trust it. I'll do it myself, and I did it myself once, and then like I had to update it. And I was like, okay, I'm done doing this. I'm just gonna find a nice template and thank the creator and move on with my life. But it is very useful when like you need to build something out really small and stuff, for example. So yeah, sum all the args. That's it. Classic reduce. Everyone loves it. Provide no initial value because when we're summing, we don't need an initial value. Takes the first from the array. It is the classic. Your words, my words, exactly, huh? Yeah. Recently, I had a so like with this Pure.js thing I'm gonna be doing like Friday or Saturday ish. Pure.js is like I never use Pure.js, but it's got types on it, so I'm like, okay, I just use some TypeScript, and then you gotta build it for the web, and I'm like, oh no, I need to figure that out, because like I make sure that I can actually do what I plan to do on stream within the allotted time I give myself. So I like do exploratory stuff. So it was like, oh no, I need to figure this out. So I'm like, do I remember enough Webpack? I don't. So I brought in require.js, compiled it with AMD modules, and just said, this is good enough, right? So yeah, build systems. Not even once. Do not get paid for that. Although, if anyone was paying for it, I would learn every build system in the book. I would do so begrudgingly. Okay, sum of... what's this? Sum of numerous arguments. 1, 2, 3... okay, it's literally the same as last one, but handle an empty array. Very cool. There it is on chat. Follow along. And I did not turn the timer on, so let's make this, I don't know, I'm going for a little bit. Not that much. Yeah, let's say we got that much time left. Feels about right. This time I will use the arguments object. That's not used enough. Reduce sum num sum plus num, where we start with 0 because watch what happens. Reduce is not because arguments is not a real array. Okay. I didn't realize it was an array like. There we go. And now to handle the reduce without an initial value, provide a value of 0. If negative arguments are passed, function should return -1. Okay, I'll figure that out. Yeah, it's kind of like automagical because, I mean, at least in my experience, I don't like using something that I don't at least understand to a comfortable enough point, because eventually that something will break. And if I don't understand how that something works for the most part in the first place, when that something breaks, I won't be able to fix it. And I don't like not being able to fix my own projects. So it's like, I have to know how it works a little bit. So when I get some weird React, Babel, Webpack error, I'm not completely frozen. I know at least something that's going on. Okay, if negative arguments are passed, function should return -1. Okay, interesting test case. Probably said that in there. Negative arguments are given, return -1. Okay, so reduce is no longer the most performant option, because reduce was just saying, we're going to go through all the elements, but if we find a single negative element, we need to stop. Hey, mouse, or mouse, or M0 use. How are you doing today? Just knocking out a few code wars. Yeah, so we can't do that anymore. Gotta loop over these normally, like it's 2015. Let sum equals 0 for const num of arguments. Now I'm assuming it's at least an iterable, so I don't need to turn array. Turn sum. So if num less than 0, aka is negative, return -1. Everyone stop. No more traversing. Otherwise, sum plus equal num. Not sum. That would not be the approach. Hey, and that is the approach. So you probably could do some reduce trickery with this, but in that reduce, you would need to track two different values, one being the sum, one being have I seen a negative number. It would not be worth it, I don't think. But that won't stop some Codewars folk from doing it with reduce. Let's see how they did it. Okay, let's see how they do this. A is less than 0 or B is less than 0. So if any of them... Okay, yeah, so this is the reduced way you do it. Still less performant because you gotta go through the entire array. So if you had 1 billion numbers and the first number was -1, you still have to go through the other 999 million ones, even though you should return -1. So it's clever, but not performant. Plus they named it A and B, which, yeah, so I understand it. If either of them are -1, then you return -1. or add them together. And since once you find the first -1, A will always be less than 0. So this will always, like, the other 999 million will always return -1. But still, doesn't feel the best. Okay, so this is some ES5 magic to convert that to an array. Okay, making sure there's... Okay, making sure it's not greater than 0. Okay, making sure it's not empty. That's an interesting way to do it. What's the question mark do? Ah, so you're referring to, like, where you see a question mark, and then something, and then a colon. So the question mark in JavaScript and other languages, but we're looking at JavaScript, is known as the ternary operator. And what this does is it's kind of like an if statement, but when you want to evaluate to something, you can use it anywhere. But the ternary operator, basically, you have your true thing. So it's going to be if this is true, then evaluate or run this code. If it's not true, aka the opposite, do this. It's the equivalent of saying if is member this code in the if block, else this code in the else block. The advantage is that it's a little shorter. Once you figure out the syntax, it's a little easier to read. Let's see if they have more examples here. Yeah, so like beverage. Plus you can use it to assign it to costs without making it multi-line. Yeah, it's basically if, else, sugar syntax. I mean, it's nice sugar syntax, and then then you see these ones where they start chaining them, and it's kind of a debate, because this is, if you're really good, you can read this and understand it, but for most people, this gets a little unreadable. So most people, like, you get one ternary, and that's about it. There's nothing stopping you from doing this and being like, this is what it does, maybe in a comment or something, so everyone knows exactly. But like I said, the one-liner is commonly used in this. I even using it like this. Yeah, chaining is crazy. Like when I chain it, like I don't format it this way, but at least I format it on multi-lines, so it's somewhat readable. But I have been guilty of this a couple of times. But yeah, at least like when they do it like this, it's kind of hard to keep track of all the things. So like if I were to rewrite this, like JavaScript doesn't have a hard time, it does humans, but to rewrite this, let me zoom and stretch. So we have our conditional in these parentheses, our truthy result in this one, and our falsy result in this one. So that makes it a little bit easier. You got the ternary, the truthy, and the falsy. And of course, this can all be done as an if-else. So if I wanted to, it would be, close that, if conditional, then you would return -1, else you would return A plus B. So, as you can see, it's the same parts, just put in a one line, made a little more concise for those instances where you don't want to do all this. You'll mainly see it, at least I'll mainly see it, or mainly use it when declaring values to constants, because if you want it to be a constant, then you have to declare its value instantly. You can't be like const empty value and then eventually set it to one thing, else set it to another. So that's a common, at least for me. The truthy and falsy. Yes, so I believe everything truthy is literally, like one of them is literally everything and not the other one. Yeah, so truthy is, so everything, yeah, so it's the other way around. Everything that is not truthy is falsy. Now what that means is it can coerce itself or be seen as truthy. So we have the string ABC. This is considered truthy because it basically, it has value is the way I like to explain it. So if we convert this to a Boolean, which we can do by this, or if we throw this in an if statement, but I like this easier. you can see that when passed as a Boolean, it sees it as true. So it's truthy. This is not true, it's a string with characters, but when in a Boolean context, it evaluates to true. That's where I think it gets the E part of it. So it's truth-like or it's truthable. But when you do an empty string, you see Boolean says, this ain't truthy. This is falsy. It is valueless. And I'm using Boolean here because it's very explicit. But whenever there is any coercion to a Boolean for an if statement or ternary operator, which again is syntax sugar for an if statement, it's not undefined, so it's true. Yeah, that's another way to put it. So yeah, with actual undefined, it's very much a falsy. So you can see this is one of the explicitly false things here. And I specifically like this definition here, on the other one actually, where truthy, God, I read it somewhere. All values are truthy except all these values. So the way I like thinking about it is you don't need to worry about truthy. You just think of falsy. If it's not falsy, it's truthy. Because falsy, you can literally memorize this. Like put it in your Anki deck or however you want, and you memorize the falsy stuff, you'll automatically know everything that's truthy. Could it be because Boolean takes it as a positive number? That's a good question. So let me see how that works. As a positive number. So if we pass it a positive number, it is true. But you also, if you pass it a negative number, that's also truthy. So Boolean, at least in this case, like I'm using Boolean. Maybe I won't use Boolean. So we have 1 question mark true or yes. We'll use yes and no and not have the Boolean conversion there. But you can see 1 is considered truthy, empty is considered falsy. So I was using the capital B Boolean just to be explicit, but I can see why that could have been confusing. But yeah, it takes it and it converts it to something. It forces it to be a Boolean, and then it does whatever the behavior is. So yeah, for me, memorize all the falsy stuff. That seems to be, oh, we're going to use the negation or the not operator, right? Not 0 is false, right? So good old exclamation point. It inverts, or no, what's the proper name for this? I know I'm using the wrong name, but there's a right name for this. The logical not operator. There it is, yep. Not negation. So it takes whatever you got and it nots it. Now, not is a very binary thing, so it also converts it to a Boolean. So every time you do this, it flips it back and forth. So a common trick, like you mentioned, is double exclamation point, converts whatever you're looking at to a Boolean, shorter than typing the Boolean, probably more performant maybe, I don't know. 0 strict equals false. So use 3 exclamation points. So that is the strict equality operator. And if I memorize it right, when the types, it makes sure the type and value are the same. So as the types are different, because type of false is Boolean and type of 0 is number, they will never be equal. But if we go abstract equality with 2 equal signs, it will coerce one of these to the other. Now let me think. I think it coerces the false to a number, but we can check that out. Abstract equality with double equals. There you go, equality. False double equals false, or 0 double equals false returns true. Yeah, because false, it coerces to a number, and if you ever were to plus false, convert it to a number manually, it is 0 and true is 1. They're just, friendly versions. Yeah, 0 is false to JavaScript. They're just friendly versions of the numbers 0 and 1. And you see that in many other languages you'll go to, like in C, for example. I don't believe they have Booleans inbuilt. They just expect you to use the numbers 0 and 1. So yeah, let me see. Comparing a number to a string. If one of them is Boolean, convert the Boolean operator to 1 and plus 0 if it is false. So there's the exact conversion for the Boolean to number. It converts the Boolean to the number, 0 for false, 1 for true, though positive 0 for false, because that's an important distinction. Because negative 0 exists. Yes, we love that, don't we? I've never used negative 0 yet. Sure, I will. But yeah, sorry, to finalize, everything that's not falsy is truthy. So my strategy is memorize the falsy stuff. Literal false is the zeros, all variants of 0 basically, and empty strings. Then you got explicit, null, undefined, and nan. And apparently there's this weird thing, but I haven't memorized that because I don't use it. No, I'm happy to do this. That's kind of like the whole point of the stream. Like, I wanna be able to help some people, you know? And yeah, it's always good, it's always good to refresher. It's not just for you, it's a good refresher for me. Like, I went to the truthy one. Like, look at me. I was like, truthy has the definition I'm looking for, and it's like, nope, it's the explicitly falsy stuff. So it wasn't a we didn't kill the Codewars. We just took a nice break from it. But yeah, I memorized the falsy, and it's like, if it's not falsy, then it's truthy. Convert integer to binary. We're gonna cheat on this one. I go straight into this one. We're like, we're cheating. Maybe we shouldn't. Let's see. Negative numbers should be handled as too compliant. I don't know if we can cheat on it now, because if we do 2 string with a base of 2, I don't know if it does turn end.to string. I don't think this does good for negatives. Yeah, it doesn't. Yeah, how's this? Yeah, I might not do this one, because this is kind of a math. How does to compliance? Sorry for the white theme. Yeah, I'm not interested in doing math today. Possibilities array. An empty array of all possibilities contains a number between 0 and a length of -1. Turns truthy array is an array of all possibilities. Okay, I can do this one. And here is the link to that one. And we will take the Pomodoro break after this one, since we kind of had a break already. Factorials. I don't know what that means. Was there a stream delay and you're referencing the last one? The weird convert integer to binary. Factorials. Oh yeah, because yesterday I was like, factorials math, I almost didn't pull it off. Maybe that's what you meant. Yeah, I'm definitely doing this one first either way. Yeah, I could see that. I could see that being a good name for him. You got the Avengers, the Factorials. Yeah, for sure. Number of combinations that can be expressed. Ah. Yeah, I'm familiar with it because I wrote like one of my calculators. I didn't do the math, and I was like, let's just go with it. And I frequently realized like how the factorial kind of bit me there. Because what did I do that? Norm Novameter. Novameter? This is it, yeah. Because I realized like, wow, this is a lot of possibilities or a lot of combinations. So I am familiar with like doing the combinations. I'm just not familiar with like knowing the math. It gives a mathematical question, yeah. So let's see. So we get 2 buttons, and we have to get negative 13. Oh, watch me fail at my own game. We have negative 10. No, we have 10 times. Oh no. Keep trying things. Nope, not those things. Nope, not the things. Brute force. This is the answer. Nope. 8 times negative 2. 6. No, 6 times negative 2. Nope. Negative 6. 8. Oh, I literally... Now, usually I can get the difficulty of 2 one, but this is a tough one. I mean, we have 5, 6, 8, 10, and 2. There's not a lot of numbers here. 13 negative. 8 and 6. No, 8 plus 6. 6 plus 8. Oh, it's gotta be one of these. So we have negative 6. Do we have a positive 6? Negative 6 minus negative? No. Oh, negative 6 minus 8. I am Factorio. Yeah, we got the Joker, we got Factorio, we got all these people asking questions, right? Is there not an answer to this? I literally don't know if there's an answer to my question. You know, this thing isn't supposed to give you impossible questions, but either I got streamer brain going on. I can't think of basic math. So they're supposed to be like the way this I probably should have explained this. The way this little game works is that you pick a random starting digit, and then you can pick one of these digit and operator combinations, and your goal is to equal this value here. So like 8 subtract negative. Oh, I found it. Okay, I need negative 8. Yeah. No, I just had it. Okay, so 8 subtract negative 5. Then I need... So it's somewhere in there. 8 subtract negative 5. 8. You know, if I go from negative 8, subtract negative 5. Negative 8, subtract negative... No, let's divide negative 6. I found the exact same one. Negative 5. Okay, I won't waste... Okay, I figured it out. Negative 5, subtract 8. That's how you get negative 13. So this is kind of like inspired off the Wordle thing. Yeah, why math? So it's, yeah, like you can do the whole copy and like share the thing and all. But yeah, it's obviously like when I made it, it's like, oh, this is cool. Because like there's 9 times 9. But it's like 9 factorial. So there's something like 300 something combinations. It's like, yeah, that'd be a cool a cool attempt. But it's like, yeah, the game's like really hard. So it's like, well, I'm done with that. if any of y'all are crazy enough to actually want to be math attacked, then here's the 9 one. The 9 one's the craziest of all, because difficulty of 9 means you have to use all 9 buttons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a lot of permutations, a lot of factorial combinations. Never solved that so far. But yeah, possibilities array. Back to some scheduled code wars. Let's think. Scheduled. What are we doing? I forgot what we're doing. Okay. Make sure all the values between 0 and a minus a length. So make sure all the values are in there from 0 to the length of the array. Okay, so we can do this the manual way for let I equal 0, I under x dot length, I plus plus. Then we'll check if the array includes it. If not, x dot includes I, return false, return true if it did include it. a manual / human math random to solve your game, right? Yeah, I mean that's kind of what I just did there for the first half, right? Just kept randomly hitting buttons, but yeah, that would be an interesting like addition add-on or like a mode to be like, let's see how long a randomized human does it. Because what's it called in pathfinding? Random rat. Because there's a pathfinding thing where this is called, I don't know, maybe it's called something else, but there's pathfinding algorithm, which is literally like randomized, where you literally, once you get to a point, you just pick a direction or pick an option and go for it. So it'd be like, yeah, this is the randomized human, just slams buttons, sees what works. Okay, so random test is failing. That's okay. Why is random test failing? Let's look at the failing array and see what's going on. It's an empty array. Well, why am I supposed to do something with empty arrays? 0, 1, 2, 3. I mean, let's look at the output again. Empty array fails. Oh, so empty array is literally supposed to fail. Okay, if not x.length. So here, it's all coming full circle. So we can check if the length of the array is 0. Okay, maybe I won't say anything till I figure it out. Expected undefined to equal... Oh, needs to return false, of course. Yeah, I'm not being random, I'm just guessing. You just can't figure out the algorithm. Yeah, okay, so back around to falsy check. So we can check if the length is 0, or we can check that it's not truthy. Put in our little not operator. Bada bing, bada boom. Exact same thing, a little more short. The Codewars community would approve of that solution. Let's see if we can optimize this even further. So we have ourselves this array. Now includes is not a free action. This is expensive. To be precise, it is O of n expensive. So if there are 100 numbers, this is going to make 100 different checks. But we can optimize that. We can optimize it by... So we could probably sort this actually, now that I think about it. So we do x.sort a, b, a minus b. And instead of checking this, we check if xi not equal I, return false. So I'm trying to think if that will do the trick. And it does. Now it does the trick only because the numbers are from 0 to n, they're expected to be. So if we put them all sorted, then 0 will be in the 0th position, 1 to be in the 1th position. And in this case, if 1 is in the 0th position, it fails. So even though sort is also not a free action, it's better, it's obviously better, because it's not inside the loop. So this is already n times n, or n squared n. It was going big and it was going bad really fast. It was one of those graphs that was going up to the sky, so it was the bad one. But here we're doing one sort. Now that's probably n at most, or it's log n, one of those efficient ones. Then we're doing a single iteration of the loop, just getting out the key, which is a constant time operation, and checking if it doesn't equal where it's supposed to equal. And that is pretty optimal. I'm thinking about putting this in a set. Now if I put it in a set, we still got n operations, but we can check the set length. Well, set does not maintain order. I don't think so. Yeah, it doesn't. So we wouldn't be able to do that. I believe this is the solution. Let's see how the Codewars folks have done it. Okay, yeah, so we're going through every... A is not used. We're just... Yeah, so essentially we're doing what I did. They just did ternary, made sure the length was greater than 0 first, and they checked every index, made sure it included the index. Same logic, same logic, same logic. First, rest, slice, sort. Okay, an interesting thing. They're making sure the first is 0 and the rest are I plus 1. I'm not really sure if there's anything special with that. Hey, here's a set. So yeah, this is more efficient than my initial solution for sure, I believe, because the has is a constant lookup, constant time lookup collection. Yeah, I think that we've seen all the variants now. Okay, and with that, we are overdue for a break, so break it is. Take a stretch, get a drink, all that fun stuff, because we have one more Pomodoro code session left, and then we will be raiding Mayan Wolf. Nah, you weren't killing the Codewars flow. Don't worry about it. I enjoyed it. And yeah, hey, thanks for stopping by. And yeah, I love going through refreshing the basics on JavaScript. You gotta do it every now and then, or else you forget, get rusty. And we ain't coding in Rust over here. But thanks for stopping by. I'll catch you later. Call me Wolf. I probably should just call you Wolf at that point. I'll catch you later, Wolf. There we go. The break coming to an end. I loaded up the next Code Wars, a binary search tree Code Wars in Python. So I know it's not JavaScript, so I will keep this very short. So given a number in a binary tree, not a binary search tree, return true if the number's in the tree, false if it isn't. So very much, if you're not familiar with binary trees, they essentially, let me look at their example. Okay, yeah, their example's good. There we go. Okay, let's erase all this. Nope, not that button. My previous drawing, what's the undo button? I don't remember it. Okay, so binary trees, they're basically this, and I'll draw it in this little box here. We have an object, because everything's an object, so we have ourselves an object. Then it has a value. As you can see, you can totally read this value, don't worry about it. And it has a left and a right. And those are pointing to either more objects, which point to more objects, which can then point to nothing, aka nulls. So they point to nothing. So in this one, we have 1, 2, 3. No one spam nuns in the chat. So this is what binary tree basically looks like. Now, binary search tree is like a smart one, where value is less than a node are on the left and value is greater than are on the right. But they're not giving us a smart one. They're giving us a plain one, in which we have to check. So if we're given the number 3, well, that's not the number 3. My mouse slipped. So we have to, and we're given this head node, so we're given this one right here. We have to check if the value is 3, and then we have to check if the left value is 3. Now there's nothing over here, so we're done. So then we check if this value is 3, and we check if their left value is 3. Then we check if their right value is 3, and it is, so we will return true, which will return true up this function call to this call, which will return up this function call, or up the, what is it, stack? No, up the stack, I suppose, yeah, to this call of the function. And that's basically, I don't know why that was kind of more of a recursive explanation, and that doesn't make this short at all. But that is basically the algorithm I'm going to implement. Before I do that, I need to get my timer started for that long, I think. It's about right. So let's check it out. If not root, return false. If root.value equals n, return true. For child, well, I don't need to do a for child. If search in root left, return true. If search, well, then we can return search in root right. I know this ain't JavaScript, folks, but you can see the logic is the same. All that's happening differently is that this fancy not operator, like that would be an exclamation point in JavaScript, and our booleans are capitalized, and like we don't use curly braces, but the logic is the exact same. But let me check real quick. Codewars.com. Yeah, this solution is not appropriate for Codewars.com. We got a one-liner. So return root and, so basically if there's a root value and root value equal n, or search, watch me mistype search 5 times, search in root left, or search in root right. Now this looks like a solution for Codewars.com. Of course it don't work, because none has no left. So this is only checking if root and, I believe this is the optimization, or like the order of operations, so none should equal false. So if this is true, or, what have I done? Oh no. Okay, so return false if root, else all the other stuff. So I'll explain this in a second after I get it working. Ha! false if not root. There we go. Okay, so this is kind of translatable to JavaScript. So basically, what was happening before, I was doing an AND with a non-Boolean, and when you do that, like that, well, let me show you how it works in JavaScript. The ABC and 1, 2, 3. So ABC is truthy, so we evaluate to 1, 2, 3. But if ABC is falsy, we got an empty string. We didn't get false. We got an empty string. And that's what happened, because the original root was null, and we were supposed to return true or false. So we got null instead of 1, 2, 3. When I changed it to was not, was, what did I do? So I said null, I said false, well I said null, that said if it was null, then I want false, but if it wasn't null, I wanted my truthy thing, 1, 2, 3. So we switch it around. Yeah, it wasn't the best explanation, but this is Python. I don't want to bore all of your minds with some Python-y stuff. But yeah, right there. I'm right there with the best of them, leak coding it away. False is not none. It's a more Pythonistic way to do it. I haven't touched Python in a while, so somewhat expected. Let's make sure it's JavaScript this time, eh? Any second now, Codewars.com. Okay, great. Please colon multiple. That sounds like math. 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 Change it up. That's math, and I think I can handle that. It's money, right? Place every letter with a letter following it in the alphabet. Make any vowel capital. Make any constant lowercase. Z becomes A. Y is not a vowel. Oh, we gotta leave right now, right? How dare they? What happened? Sometimes Y. This is the sometimes they meant, huh? And Codewars.com, Y is not a vowel. That's okay. So that's a fair amount of logic. The letter following it in the alphabet. So this is not a new concept, but basically A becomes B, B becomes C, all of them, and the wraparound, Z becomes A, and that new character also follows the rules. So we transform the letter first, and then, so we rotate the letter, then we do, so, oh, okay. If I would have read the problem, so, reminder, read the problem, folks, in this order. So first we do this, then we do this, and lastly we do that. So once you read it in order, it makes sense. So return, well, yeah, we're gonna Codewars it initially, I know. So we're gonna spread the string into an array. We're gonna map it from car to car code at 0. That gives you the character code representing the number, or the number representing the character, okay, the character code. And we're going to add 1 to that. First, we're going to lowercase this. That's probably a better way to do this, but I don't know it at the moment. So yeah, this converts it to its character code, lowercase, +1, modulus. So I have to get the character code, the last letter of the alphabet. Car code at 0, so 122, it needs to wrap around. So something becomes 122, so it's 123, it needs to wrap around, right? So when I go to 123, it wraps around to 0. Good, but okay, I think I need to do this math differently. Car code at 0, so I need to subtract 97 from every number, and then modulus around the number 26. Okay, I think I got that. +1 minus 97 modulus 26 plus 97. And it's all probably off by 1, but YOLO, you only live once. More parentheses. And let's convert all this back to character. Well, it's going to be string from car code. And this is a static method on strings that takes a character code and converts it to its string representation. DBUNK. DBU. Ooh, numbers. Numbers are not modified. Okay. Only on characters that are alphabetical. Okay. I'm gonna cheat with regular expressions, I know. Alright, match AZ, A hyphen Z, so if between A and Z. Ignore case because I haven't uppercased it at this point because I'm lazy. If this is true, this. Otherwise, use the original character. CAT30. Okay, global flag? Oh, the flags need to be outside the second ending slash. And I just use that. So DBU30. BMJ. So let's see how Z does. Expected A, got A. Okay, so my wrap over through only a miracle. The math was first try. First try. Okay, so now we have this lovely one-liner, and I will be friendly to the eyes and format it. That's how you format a Ternary Operator, folks. You just put it on 2 lines. Although you probably could do more, right? Yeah, I don't know why these are code pens. Like, you need this white space. I'm like, no, code pen, I don't need this white space. So now we have all these characters, and we need to do this thing where all vowels become capital. So already locating everything else. A giant constant, which is a new set of vowels, A, E, I, O, U, and not Y, unfortunately, or Y, plus car. Now we're gonna do something absolutely crazy. We are joining the Code War elites. We are nesting a ternary operator. Don't let this scare you. Oh, vowels. If it has the character, if this character is a vowel, then here comes the nesting. I'm gonna make it readable nesting, which sounds like an oxymoron, but it is possible. So car to upper case. Otherwise, it is colon just car. Of course, can't put that there. Then you join it back together. I mean, it depends on how you nest the ternaries there, Gene. Or Genie. Like, if you nest them readable, then no, surely not. But if you nest them all on one line, I don't know. It definitely wouldn't get accepted on my pull request. You at least gotta make it something like this. And then put a giant comment. No, maybe the comment would be explanatory, but like I can read this. So if character matches A to Z, then we're doing this. Otherwise, so like this is the else if, and this, so we have if block, else if block, else block. So I can read this. But if you did this, I can't even see this, not let alone read it. So like I have to process through it character by character, and now I gotta scan this like basically one character at a time, looking for that colon. It's like, okay, there, I found it. I gotta scan that. So now I'm already here. I'm like, wait a minute, how many ternaries did I pass? Let's scroll back. Well, there were how many ternaries? There was 1 ternary. So like I'm good at ternaries. I just like them formatted a little. Let's see what's wrong with this. DBU, AEIOU. If vowels has character, has card uppercase. Great thing about writing ternaries is good luck debugging them. Vowels. This is a vowels set. Let's do some sanity checks. Vowels has A, right? We're not crazy. You're crazy. Okay, yep, vowels does have A. So vowels has car. Have I never lowercased it? Yeah, let's be paranoid. Let's lowercase it. DBU30. Vowels has it. Oh yeah. Good luck debugging these, right? we're gonna have to do it. I know it breaks my heart. We are deternarizing it. So let's console log. Wait a minute, dbu. Am I outputting that right? dbu. Yeah, so I'm getting dbu. Oh, I still need to perform the rotation. I'm not rotating it. It's also not... Okay, I don't know how this is working. But they all need to be rotated, right? So I don't think a ternary is possible for this. Rotated. Well, let's just... Yeah, we're doing it normally. I know. Disappointing. I failed. I am not among the Code War elite. So if there's no match, we return the normal character. So if const rotated equals here, then we do this. So okay, we still get one ternary. We just don't get a bunch of them. Turn if is... No, we're not using car anymore. We're using rotated. And this should already be lowercase, but I'm paranoid. There we go. We were to lowercase it anyway. So that's what was going on. Now, if I was in Python, I could use something known as the walrus operator to save this rotated thing in, like, the expression as a one-liner, but I'm not in Python. We have no walry in JavaScript. Yeah, let me see. Val has rotated, rotate uppercase, or just rotated. I still have to check that, so I need at least 2 instances, one on the conditional, one on the return. I can't do anything else. This is it. I can't optimize it further. I need that. No one-lining for us today. Oh, I don't need that log anymore, though. I probably not use regular expressions here, but I'm cool with regular expressions. Regular expressions are cool with me. We are chill. Okay, that was a good one. Replace all characters with... Oh, yeah, that's smart. Literally use regular expression in the replace statement. Yeah, okay, I did it very manual, I suppose. Can we get explicit alphabets? Oh, we get... Ah, okay, you hard-coded the capitalized ones. Okay, yeah. D, H, and T, or... I'm not even going to look at that. I don't understand any of that. Okay, string merge. Might be the last one we get in. Hello world L. Given 2 words and a letter. Combination of both words to merge to the point where the given first letter appears in each word. Should have the beginning of the first word and ending of the second with the dividing letter in the middle. Oh, this one actually seems cool. I mean, the rest of them are cool, but I can completely understand this one. Okay, so person, here, E, P-E-R-E. Okay, so I find A1, because I'm great at naming things, string 1, index of letter, then const A2 equals string 2, index of letter, and I'm going to return string 1 slice from beginning to A1 plus string 2 slice from A2 to the end of the string, and it's going to be off by 1. Well, it's also going to fail because slice 9 isn't a method as much as we wish it was, and it won't be off. I almost had first try. No. That's okay. Do we count typos? I don't count typos. The compiler probably counts them, though. So yeah, a little slice magic, because that just works. And I think this is literally the most optimal solution. Yeah, you can't get any more optimal. Well, so this is an iteration over this string. Yeah, I'm saying this is optimal because I'm banking on the fact that slice is more optimized than me manually for looping through this. If it wasn't, though, then a for loop through this, like building, like let first equals empty string and adding character by character to it, like P, and then, well, I won't find any more for person, and then doing that for second. Now on second I literally would slice because there's no point in traversing through it, but that was only if slice didn't exist / was had horrible performance, and for some reason manually doing it did. But I don't believe that's like, I don't know. This is Codewars.com. I like this, and this kind of just works. Yeah, I think this is good. Yay! Oh wow. Okay, I didn't join the Code Wars Elite today. I didn't arrow function and make it unreadable, but the concept is there. Ooh, we have. So someone really hates string concatenation and really loves template expressions there. But yeah, looks like everyone's got the same idea. Some people use split. Ah, yeah, you can split. Say how many times you're gonna. I'm confused. I don't know. Is that how split works? You see D dot split C, and if I say 1, yeah, that gives me the array plus. Oh, okay, so we're dealing with a little type coercion. So when you take an array and you plus it, it stringifies the array. And if the array only has one element, then that just gives you that one element as a string. Okay, TypeScript would not like this, but that's pretty neat. Oh, what's this regular expression? No. Run away. Okay, let's check something. Counting change. Oh, that's a 4 Caillou. What is it doing in my search field? How many different ways you can make change? Nope, that's a permutation. Sort by binary ones. Oh, I think I can do that. Do we have to do any 2's complement, handle the negatives? We don't. Yay! Okay, so. You know what? Yeah, okay, I'm pretty confident. Okay, this will probably be the last one then. Maybe. I don't know. And let me check something. Yeah. Clicky, clicky. Okay, I was just making sure things were not on fire. Oh, there's literally a thing there. Yay! Okay, good. Back to the track. Sort by binary ones. So we're going to return. Well, let's do it the bad way first. List.sort AB. And what are we sorting by? Sort the list based on the amount of ones in the binary representation of each number. Okay, so a.toString. This converts it to binary. And we count the number of ones. Oh no. Match 1 or empty array dot length. Is that how we do it? Count the number of things in a string. I hope it is, because now I have to duplicate this for B. So it's B. Okay, let's just see if it works. 1 3 to equal 3 1. That's okay. When you sorts are backward, just swap them around. Oh. Okay, so our counting is obviously wrong. So 2049. How many ones do you got? 2049. Oh, show me the console. Oh, yeah, for a number of ones. Now let's actually perform our logic on you to count them. And here, dot match or thing. Yeah, this code's getting real ugly. 2. Wait, what? Oh, yeah, so. Oh, yeah, okay. I was confused by the output. Let me look at this. Yeah, so this is it being outputted so many times. What are we supposed to do with this? Ooh, if strings have the same length, lower decimal numbers go first. I'm not handling that. Let's handle that. So no more one-liner. Here we go. So where are my parentheses? They're all messed up. So const AB for A binary. Then we const BB for B binary. These are great names, I know. The best names. Okay, so if AB not equal BB, turn BB minus BA, or AB. Here's a free lesson of why you don't name them such bad variables. Lower decimal number goes first, so return B minus A, right? Of course, I have to fix this by adding my parentheses to my janky of janks. 342124. 3124. Okay, so one of these is going wrong. If I had this working at one point, let's undo this, make sure my orders are right. Return BB minus AB. I might have gotten this wrong. Which means my second one is out of order. A minus B. There we go. Okay, this is it, and it's not the best, but I can make this better. Const. Then what do we have const here? We have const binaries, so we're going to map all this. List.map. All the numbers are seen here only once, right? They're unique. You know, I might do this later. I'm trying to figure out how to optimize this. We're performing this comparison multiple times. We shouldn't need to be. And think of how to optimize this. Because I need to do it all once and then index them right to the thing. You know what? Yeah, I think this is the best way I'm going to do it. I can optimize this though. Turn BB minus AB or A minus B, because if that's 0, that'll go to there. Which means I might not need to variabilize these, which means I could one-line it. Nope. The math doesn't help. There we go. Let's be Codewarsy. Yes. Yes, unreadability. The Codewars way. Oh, can't even see the end of the line. There we go. Now, this will be a better way to count decimals in a thing, but this is acceptable for me. Okay, and that is it. Oh, they replaced the zeros and count the length of the string. It's a little better one. Sort, choose, sort. Okay. Okay, so it seems like a lot of people went the binary way. Got some manual counters in here. Very cool. Okay, that's neat. Wow, this person was like super. Oh, Ramba. I think that's, yeah, I've heard of that. Functional, pipey way to do it. Yeah, that is good. And that is the last Codewars. So appreciate everyone stopping by. I know there's no project, but just a few Codewars. Yeah, you have fun. I'm gonna jump onto and raid Mayan Wolf. Gonna hang around there for the rest of it, and probably, I think that's probably it. We'll do some other stuff later tonight, but personally, yeah. Thanks for stopping by, Gene. Hopefully, I was able to explain that object deep equality a little better, and both here and personally. And yeah, wish you luck. Catch you later. When I push this button, you know, I get to fumble pushing buttons for a few seconds. There's the button. Button, where is the button? Okay, Thank y'all for staying by. Be sure to enjoy Mine Wolf. They're gonna make Jeopardy!